Hello, this is Domenico with Easynomics, and this is another paper 3 type practice question utilizing the production possibilities curve. This will be part of a playlist for the first unit, the introduction of the circular flow, and the production possibilities curve, which will be linked in the video notes below. If you need a brush up or a review on the PPC curve with constant opportunity costs, what causes shifts of the PPC curve, and increasing opportunity costs, I recommend that you review the content within these videos. This video will be part of this playlist, again, as a paper 3 type practice. It's part 2. There's a previous video looking at constant opportunity costs. So here we have kind of a paper 3 type question. We've been given data and we've been given a graph, and the IB has given us a graph with the PPC curve, in this case labeled PPC curve 3, already plotted and labeled for us. So in this table, here we have wheat production versus production of rockets within a country. And we can assume that the allocation of resources don't easily transfer from wheat to rocket production because they're very, very different outputs being generated. And you might have to train labor as we add more and more outputs of rockets. You might need to train labor that's not skilled in rocket production to be able to produce rockets, and that will take time. And in the time it takes to train them, they have lost opportunity to generate wheat on the other side. So there's a video, again, in that playlist, it'll be linked below as well, that provides an explanation of that in much greater detail as to why the PPC curve is bowed outward. So let's take a look. It says in table 2 up here, complete the marginal change columns for wheat and rocket production. So here we have marginal change, these columns here, and so we're just going to use basic subtraction to calculate the rate of change. So here we have 100 minus 94, and so we have wheat production declining by 6 million metric tons. Even though we don't have the values here from the previous question, we're assuming millions of metric tons. And I'll go ahead and also kind of label this. I should have done that already. This will be the quantity on the y-axis of wheat production going from 100, and then here we have the quantity of rocket production going from 0 to 10. So quantity of rocket outputs, rockets. Great. So we go from 94 to 86, 94 minus 86. We have a decline in wheat production by 8 million metric tons. And then we have 86 minus 74. Then it goes down by 12 million metric tons. And then 74 minus 50 goes down to negative 24 metric tons. And 50 minus 0 is negative 50 metric tons. So here we can see that the opportunity cost is increasing. It's not constant. It's not a fixed number as we reallocate resources away from wheat towards rocket production. As we go from point A to point B and reallocate resources, we see that the cost in wheat production is increasing more and more as we're taking resources that are not suited towards rocket production and best suited for wheat production, as they're forced to produce, in this case, an additional output of 2 units, as we train labor that's better suited for wheat production to produce rockets. In the time it takes to train them, they have lost the ability to produce, in this case, 50 million metric tons. So we can see that the opportunity cost rises, start increasing more and more. All right, we can see we go from this point, then the distance between these 2 points gets a little bit larger, then it becomes even larger, and then larger again. Even though we're just producing the same amount of output, here we get plus 2, plus 2, plus 2, which we'll add in just a second. So again, here we have negative 6, then it goes negative 8, negative 12, negative 24, and here's negative 50. So that number just keeps increasing, gets larger and larger and larger. On the rocket production, we can see it's relatively constant. We increase production by 2. 2 to 4, we increase production by 2. Increase production by 2 again, by 2 again, by 2 again. So here we see plus 2 on this side, plus 2, plus 2, plus 2. So it's stable here, But we can see it becomes more difficult in this case to go from 8 rockets to 10 in terms of the opportunity cost. We're taking land, labor, capital resources that are best suited towards wheat, and we're forcing it to produce an additional 2 units of rockets, not very suited in the time it takes to generate those additional 2 rockets. From 8 to 10 rockets, we could have produced 50 million metric tons. So good, we've done this question, and it says in reference to the marginal change data in table 2, state whether the PPC3 curve illustrates constant or increasing opportunity costs and why. We can state that the PPC3 curve is not a straight line, is bowed outwards. It has a bowed outward shape, illustrating increasing opportunity costs as reflected in the marginal change data for wheat production. As rocket production increases, and again, this will be in the video notes below, increases by 2 additional units, we see the decline in wheat production not being constant, but increasing from -6 to -8 to -12 to -24 to -50 units. And then I can go on to explain that that is a result of the resources not being easily reallocated from the production of wheat towards rocket production. As we take ill-suited resources, land, labor, capital resources that are best suited for wheat production, and force it to produce rocket production, it takes time to retrain or retool machinery, and in the time it takes to readapt those resources towards rocket production, we've lost an increasing amount of wheat output on the other side. And that's it. If you have any questions, you can comment those questions below. And don't forget to subscribe and like. Thank you so much.